it's recording now.
Okay,
Hello,
so
future
just
people.
to explain, hello, future people as well. So just to explain what we are doing here. So we started replicating a warrants abstract machine. Uh, what we have so far is basically an AST with a variable and a functor. Atoms, they are functors with arity 0. So elements will be empty. The arity will be 0, and they will just have a name. Variables, they simply have a name. Uh, and those are the only two things that we have right now.
Yeah,
We might
constants are
consider later,
structures with arity 0. I saw.
yeah, we
I've
might consider later like primitive data types like integers and etc. But that's not on the L0 uh, scope
Yeah.
as of now. Okay, so we already defined a placeholder for the evaluation scope, which was going to be to make a question. To make a question, we basically send one term. So uh, since we are on L0, we don't receive a list of terms, but rather just a term. And then with that term, we execute a query of that guy. And then we produce a list of maps that represent the possible assignments to make the predicate true
Yeah.
in the question being provided
Yeah.
with the program.
And a little bit more
So,
details. Magenta has a very strong ambition of trying to make this a compiled language and a language that can be hooked into a physical layer of a database.
anyway, I have a thing on that to discuss first order logic and second order
Yeah.
logic and implications of that. But
I don't
anyway,
know how far on Mageta's ambitions we're gonna go, but I'm gonna do my best, and I think Marin will also.
well,
Yep.
having something that we can query, that we can plug anywhere, I think that's gonna be good.
Yeah.
And I think we can do some sort of that. So once
I
we have the
yeah, I
inputs.
think we're capable. It's just that, well, steady effort. That's the thing.
Yeah, okay.
So,
So
do you want to
let's go
follow
to
the order
the
of the manual, or do you want to go laws, Magenta?
let's follow the order. I think that's
Okay,
better.
so let's start by
So go
implementing.
dictating for me because I'm gonna move it here.
Sure, I will dictate. Okay, so my
Okay.
suggestion, and I would like to have Marinho's input, is to implement the functions that he's describing. So the link for the manual will be in the description of the video anyway, and in the repo, so it's easy to follow. So the first three functions that the guy is describing is put structure, set variable, and set value.
So
And
which one first?
let's do put structure first.
Put structure.
Yeah, so
Uh,
go Marin.
I found a finger tree implementation for OCaml.
Yeah,
I
but
don't want to try using it. Just saying.
no, we will definitely try to use it, but not now.
It's in a library called Batteries.
Oh, I
Um,
heard that one before. I heard that one before. Anyway, so
okay, what does it need to do? Describe to me. Let's do a literate
yeah.
opus.
Okay, so I'm gonna
Literate
read the
programming.
verbatim from the manual. So put structure, push a new str and adjoining functor cell onto the heap and copy that cell into the allocated register address. That's what
That's
is written.
still okay. That's describing the f- the implementation details, right?
Yeah.
I how it works, how it operates. What is the purpose of this function existing?
It creates a new structure on the heap.
Yes.
Right.
Yes.
That's better. Creates a new
So I
structure
think that we
on
should
the heap.
receive as an argument for the put structure function the heap.
Yeah, so what will be our heap? That's
That's
the
what Marin was talking
question.
about. However, I think
For
for
now.
now we can use
Yeah.
sequences, like just sec,
Okay.
seq,
Sec of what?
uh, of cells. We need to define what the heck is a cell.
Yes, exactly. So
Well, a cell would be just
A tuple.
no, actually.
Really?
A cell would basically just hold an address, an index into the heap, and a type tag as well.
Yeah, we need a tag. That's one. I think the tag actually should be an enum, like ADT.
So okay, it's gonna be a discriminated union of.
So there are two parts of it. There is the tag and there is the index. Right, Marin?
Yes, the index is basically just an index into the heap, and the tag tells what type of data you expect to find at that position of the heap. Um,
Yeah.
and the possible values for the tag are str, which is a short for structure, and ref, which is short for reference.
Yeah.
Okay.
So I would say, yeah, but we also need to accommodate the other guy, right, Marinho? Because if you look at the example, and it's very hard to show this. So I'm gonna
Oh,
also share my screen.
I suppose technically, let me see.
Magetta, please look at my screen.
Let me see.
So do you see this?
Yeah.
This is a bunch of cells. Okay?
Yeah, I remember
So the
this.
first one that we were describing is this one.
Mm-hmm.
So
I
it has a
suppose
tag
technically it
and an
could be a
index.
functor as well, right? Well, not just a complete, not a complete functor, but just a tag plus a number of elements.
Mm-hmm.
And then there is also there is this one, which is going to be a case of the discriminated union, but there's also this case.
By the way, I had an interesting discussion with Marin of why they would call this a structure last week.
Okay, can you share that then?
Do you recall the question, Marinho? What was my answer? Because I gave no, because I gave an answer and I was like, okay, that makes sense, but I'm not sure if I don't remember
The
what you.
question was, why do they call it a structure when this is not actually a data structure in the conventional sense?
I
This
think
is
I
more like
said
an
something
expression, you
about.
know?
I think I said something about because it builds a branching structure in the tree when analyzing a predicate, right? To analyze if it's true or false, the validity of it. It was something related to that. I don't recall exactly. Yeah, that's okay. That's unfortunate. But if I remember, I'll bring that up because that was
Where is a functor? And these are references to the heap addresses. Okay, but we need to model the ability to have these, a sequence of these.
okay. What's the number again? That's
Is
the
an
amount,
address, an
This is an
address.
index. This number is an index. So it's an address because this
and
is
then you
referencing to
define
this.
h, and then you refer to two. That means it's assigned to itself, so it's a variable initialization, right?
Yeah.
Okay.
Oh, that's an unbound variable to be more
Yeah,
Unbound
unbound
precise.
variable.
variables are the self-referential ones are unbound variables. I also remember
Mm-hmm.
that.
Can I say that's really, really bad if you want to have any kind of garbage collection?
Sure, you can say that.
Oh yeah, it is.
Anyway, so here's how we are doing it. I remember that this is some sort of like this is describing what this is. So this is saying there is a structure at this address, and then
So
this is it.
one thing here, real quick. How would
That's
our heap work? Like what are the operations we need to do in our heap?
That's a very good question. There are three
Because we
operations.
can because here, look at my screen. We can do this here.
Yeah, but there are three types of operations that I remember from reading. Indexing,
And then we
pop,
can
and
do
push.
indexing, pop, and push.
Yeah, because at some point the author suggests to use stack operations on the heap.
Okay, so let's do the following. I don't remember no OCaml, but we're gonna use of a random variable, right? So let's put an thinking. That's not Haskell.
Yeah.
In OCaml, yeah.
Manu, I have a question. Do you remember how we're gonna represent this?
uh
I don't.
Wait, OCaml doesn't have sequences
No, it
the
does.
same as in
It
F sharp.
does. I
you
don't know
need
if it's
to
the same.
grab well, you need to grab well, depends what you mean by sequence, right? If you mean a general purpose finite
Ah, no, it's
sequence,
the module, man.
you need to grab the batteries because apparently the batteries
You
don't
need to
come with
grab the batteries.
yeah.
Okay, but let's go back. Marinho, do you remember how we're gonna represent this
I can do
in the data?
this.
I mean, if we plan to follow the book, Exactly. We should represent the entire store, which the heap is a piece of, as essentially a header for us to execute.
Wait, it cuts for me.
Oh, that shouldn't be it.
Like if we are
Mm,
following the book exactly,
Mm-hmm.
we should represent the entire store as basically a large sequence.
that should do it.
No, that's okay. That's okay. But my question is about. Can you see my screen?
By the way, I got
Uh,
confused because the sequences in OCaml they are in the module, right?
They are in
In
the
F sharp,
module.
oh,
it's just list or sec.
okay, I'm looking at your screen.
I'm asking how we're gonna represent this thing.
That's basically a header for a struct. We need to add that to the possible value of a cell, basically.
Yeah, but how are we gonna describe that? I agree it should be a possible value of a cell. I agree. I just don't know what we're gonna put in there.
Uh,
Are we gonna put the name and the arity and that's it?
that's sufficient for now. It's obviously not that efficient if we plan on. We would probably, yeah, if we plan to do like an actual byte code for this, we will need to rethink
Mm-hmm, mm-hmm. Yeah, but for
the
now it's sufficient,
representation.
right?
Yeah, but for now, just basically the same thing as a structure in
Yeah,
the AST, except without the payload, just the name and the arity.
yeah, that's okay then. So we're gonna have the discriminated union will be like you are either this tuple of being possibly a structure or a reference in an address, or you are a name, a label, and an arity.
Yeah.
Okay, okay, that perfectly works.
Oh, there are some interesting functions here.
Yeah, sec is one of the most complete modules from my memory back in Camelot because we tried using lists and they sucked. We tried using what was the other thing aside from lists in F sharp and sequences?
Uh,
Arrays?
arrays,
Yeah,
yes.
arrays also sucked. And then I just said, okay, apparently everything is you are supposed to convert to sec, use it, manipulate it, and then convert it back to what you actually want.
That's it's an interesting practice, to say the least.
Yeah.
Uh, drop. Do we want to pick the value back on the pop? We do, right?
I don't remember. Marinho, do you remember if in the pop we use it, the value?
Uh, Let me double check. Um, I think the pop would be mostly for. Well, if we're using immutable sequences, then we actually shouldn't, because we can just look at the top, like at the first value, if we want that, right?
Well, that is true. And also in the unify function, I'm only seeing pushes. Do the author uses pop? What the fuck? Am I
Mm,
missing something? Maybe we don't need pop, and I was just misled.
maybe that's later. Maybe that's later because this is just L0, right?
No, but he said that I remember he's describing for this we're gonna use push and pop, and I said, oh man, Marinho is in Nirvana right now.
Not really, because there's a difference between a stack allocated in the heap and a stack inside of the actual processor.
Well, okay, maybe not
Uh,
complete Nirvana.
okay. I should return. Actually, no, I don't need this. I can just return the very same heap. So I don't care for the value, right, that I'm popping.
Yeah,
So
for
just
now
this.
just exclude it, just drop it.
So we just
Uh,
drop the 0, and that's it.
and we should probably also have a top to
Oh
let
wait.
us look
Oh
at
man,
the.
wait. This function doesn't behave the way I wanted.
But I agree,
Ah,
and I agree with Marinho. We also should have a top.
drop
Should be
in numbers of a sequence. Blah blah blah. Oh, so I
should be
need to
drop
put
one.
one.
Should drop
Yeah,
one.
should be
Yeah.
drop one.
Can't I drop like the head of it? Don't I have a pop? I don't. That would
Maybe
be very
there's a
handy.
tail function, like Haskell head and tail.
Let's see. Module sec. Okay.
Ah, come on. Forever ints memoize, repeat. Cons, drop while, filter, group, init,
Oh, there is a tail
interleave.
function.
Well, tail, I think it just picks the tail, right? That's it.
Yeah, that is true. That is true.
Force while,
Why
compare.
Vegeta using the LSP?
Yeah, whatever. I'll just. That's why I like LSP, man. It reduces the amount of time I have to go on. Bullshit. Okay, so that will
We should
be
have
our.
a top as well, aside from like let's
Oh,
add
right.
an extra operation there.
Oh, it's more like peak, I guess.
I don't remember. I don't know the difference. What is the difference, Lord,
Well,
Stackman, Marine?
my understanding, the peak is just look at the top. That's it.
That's why I propose to call it top because, well, that describes what you are looking at. It's the top of the stack.
I don't care
Well,
about the name.
I'm sorry, Marin.
I'm sorry.
I mean, peak is an acceptable name. It's just longer.
Wait, there's no head. We've got to be. Oh, man.
Wait, wait,
Makes
wait,
sense
wait.
because sequence, I think, is lazy.
The sequence is lazy. We already read that.
Yeah, that's the same in F sharp. So, uh,
Just do a.
list of all peak conv.
Oh, okay. The function in sequence is called uncons.
Uncons, thank you. I was despairing.
Yeah, but you're gonna have to pattern destruct that though.
Uncons, this.
Yeah, pattern match on the option.
Oh, okay, so because it's safe, right? So it
Yeah,
tries to
it's
do.
safe.
Okay. Heap. Okay.
So
Let's be
do a
smart.
match. I don't remember what is the syntax for pattern matching in OCaml.
Um, it's just same in F sharp. We can do
Okay, so it's
match
match.
with uh
uh,
some.
can't
Does it
can't
give
you
a sum?
just make the peak return the option?
Yeah, I can.
Oh,
Because we
Oh
will
wait,
have to handle.
it returns a. It returns a tuple of the value plus the sequence.
Wait, what? Why?
Well,
oh, this is
in
actually
that
doing
case,
the pop though. This is actually doing pop stuff.
yeah, exactly. So let's. I don't have pipes. I forgot about it. Okay, let's do val value
I
whatever
mean, I suppose we could put that inside of pop if
option.
we want, because well, it does what pop is supposed to do. But
Well, I can just do this, man. So pick the value.
Wait, but uncons is probably not. Well, no, it is probably O1. It is probably O1. I was just about to say our peak is less efficient because of lows.
I'll
I
be
mean, it
quiet.
is less efficient because of the indirections. But
I don't need this. I'll just pollute the code. I do need the parentheses. Actually, OCaml has the. Okay, that's the good thing about it. There we go.
Marine, do
Uh,
you know what is that?
that's basically the dollar sign from Haskell,
Okay,
right?
yeah, you do know
yeah.
what is that. Cool.
Okay, so that's it. And then, actually, OCaml doesn't have composition, right? Because this will be just a composition, and then you eliminate the argument, and
No,
that's
no,
it.
there is a composition.
What is the
Wait,
composition?
wait.
It's
I
not
maybe I'm
this.
confusing with. Yeah, maybe I am
This is F sharp.
confusing with that.
No, that's not a thing here.
Okay, so let's
Wait,
search.
Camel doesn't have dot.
It doesn't have dot. That I
No,
know.
I don't think it does.
Wait
You
a
need to
moment.
define it yourself.
That's
Yeah, there we go.
that's very sad.
Yeah, and
And
sorry,
they are
I'm not
proud of
using my
it.
own.
And they are proud of it.
Yeah, it's you do it yourself, right? You should have your standard library.
No, 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 no. Actually, they are proud that they don't have it because they don't like composition. They prefer
That's
having a
But
bunch of
that's
lets.
bullshit.
but
I don't understand. You're asking the wrong person, man.
Which in the
okay.
end is still just a bunch of lambdas. So it is indeed composition. But anyway.
Yeah, there's no vanilla. There's no
Yeah,
vanilla.
whatever, man. Let's just leave it this. Let's leave with the insanity.
Oh wait, there is one. They made a module called fun.
How fun.
Yeah, you can use that. You can definitely use that. Search if you
But
can
now
find
have to.
it.
It's gonna be more verbose than just passing here. So like, what's the point?
Oh, well, this thing is the same as dot. It's just more verbose. So
Yes, I'll have to type the module like fun. Man, look compare here. Okay. Okay, let's compare. So here's the function pick two. Okay, I'll remove this. Then now it sees just a random thing, a value, right? Which
yeah,
is, and then we do fun dot compose,
yeah,
right? Is that the module?
yes.
Why is it okay? It's just okay. The types exploded there, but that's it. And then you just pass this guy, which is the first that takes a. Oh, it's actually the second first, which is
It's the second
right,
first. Yeah, it's the second first. Exactly.
which is this. And then you put this, which we don't need anything. This. Is
Are you
that wrong?
sure?
This returns a weak option, two-way option, and the second thing picks a. Is that flipped?
You need to pass the second function first for to
Yeah, that
decompose.
was right. That
It's
was
kind
right.
of like Haskell in this sense.
Yeah, because this would uncombs the head, the heap, and then it would go here, producing the input that it
Oh, but the
expects.
compose is unbound, so maybe that's why it's complaining.
Uh, let me see. Oh, come on.
Well, but
There we go.
maybe this is not in standard library. But
Unbound function,
it is
unbound value
saying
from compose. Indeed.
no, but it
Why is
is
it showing on the
saying
last P though?
no, exactly. It is saying in the documentation that it is in OCaml 4.
Oh, okay. Whatever. I can leave without it.
Okay. Anyway, so now that we have that, let's finish the cell. We need to add more stuff in there.
I'll call it top just to please Marinho.
Nice.
Amazing.
You should please Marinho, man. When Marinho is pleased, he's way more excited. Okay. So we need to finish that. So I think I'm still sharing my screen. So
So
here's
both of these things they should have a index, right?
yes, both of these things should have an index.
Okay.
But
So I'm just gonna put an
I have a
integer here.
suggestion. What about making an ADT just for the tag, like call it tag, and you're gonna have structure and references options, and then you put tag in there instead of duplicating of int twice.
Okay, think about that and pause because I'll be right back.
Okay,
Okay.
I'm gonna pause it right now. Okay, so now we are back recording. So this is the implementation. So what is this doing? This is putting on the heap this tuple. Okay,
Actually, it's a cell.
it's a cell. Well, it's a cell.
Which is the tuple,
And
yeah.
it is using H. And what is H? H is a register that saves the next available cell in the heap.
So
Address, the
it's like
address
a
of it.
okay. So it's always the size of in our
Exactly.
case, right? So
And
It's
it's like
then
that.
basically the yeah, it's basically a stack pointer.
I counted with Marin. One, two, three, four arguments. And then Marinho said, why don't we make a record that is the computer? Or in this case, an abstract machine. And then we, instead of passing many separate things, we just
Mhm.
pass the computer.
I see. So like a function that receives these two, right? Plus
Yeah,
the other arguments
Yeah,
that it concerns the operation.
yeah.
exactly.
Basically, an instruction is a function that takes the current state of the abstract machine and its arguments, which in the case of put structure is the functor and the
Mhm.
register, right? And it
Okay.
returns the
So
new state of the machine
And
afterwards.
apparently this is how elevator chime was done.
okay. So let's go back here.
I mean, if you desugar the object-oriented goofiness of Objective-C, this is kind of how
We did
the
it, yes.
original Chine works as well,
Yes,
right?
exactly. We also did it like that. Okay, but let's
So
finish
this
cell.
is
Cell
our
is not done
abstract
yet.
machine. We have our cell.
No, but cell is not done. Let's finish cell first.
What
So
else is needed
okay, so
here?
let's create a new type before T and let's call it tag.
Oh, okay. That's the thing you wanted to do.
Yeah,
Okay.
and I also want to use the names of the paper instead of using these long names that you proposed. So str and ref.
Ah, man, that's so cringe.
Okay, so I let's use the complete names then,
Like, I don't see the point of just putting str,
just to be able
but
to
okay.
follow easier the.
Okay, I'll do it.
So just
Okay,
put
go
in
on.
there str and ref. No, that's what we're gonna put in tag str or ref.
I see. So you want to make the structure a record,
No,
and
no,
then
it's not gonna
here
be a record. It's gonna be still a discriminated union, but it's gonna be a discriminated union in which one of the cases uses a tag on the T1.
I don't follow. So okay,
That
what is
so
it then?
tag of int in there.
Wait, this?
Yeah, tag of int. The first
Okay, so I keep the indexing here.
well, I don't know
Okay.
where to put the int is better. I thought in the T, but okay. Then this can be a tag or
But
this can be
wait,
something
man,
else.
wait. I'm confused. What do you
Sure.
want me to put here?
Not there. I was proposing nothing. Just that
Okay, so you said otherwise. Okay.
tag and
So
then of
T
int
tag
of
of
int.
int.
And then there's another case that we're gonna
You
use as
also
well.
need a tag as well, because otherwise, that's actually a pair, not just an
Yes.
integer.
Yes.
By the way, I am struggling with this, so let me go
That's fine.
back.
That's okay. That we can use it complete names.
I'm
But maybe
struggling because it looks like ugly with
yeah, but
ref.
maybe Mageta's idea of putting the int on the tag is better, Marin. What do you think? Instead of saving a pair
I
If we're
don't need
gonna
a.
do that, we may as well just go back to the original union.
and flatten the entire thing, right?
Yeah.
Yeah, let's. Okay, are you following Mageta?
Okay, going back to what it was.
Yeah, because well, I actually prefer the separation, but that's just me.
Man, okay, we can always just redesign this later.
Okay,
That's
and
not a
there's a
problem.
third one. The third one will be um, a label, so a string. So it's going to be a pair as well, right? So we need the
It's gonna be
tag
a
first.
yeah, it's gonna be a functor of a label
Yes,
and a narrative, basically.
exactly, exactly.
Okay.
So functor in there of a pair of a string or a record, whatever you
Let's
prefer,
put the. I'll put the string
and
and
an
an
and an
integer.
int. Yes, that's it. That's it for a cell.
We also need the number, right?
Which number?
No. Oh, actually, no. That's the. So okay. Every tag has this. It's not optional.
Yes.
That's fine. Yeah. Okay.
Okay, and now we can go to put structure. So the arguments of put structure, and you can see my screen if you want to double check because I'm sharing that part right now. So put structure receives two
Mm.
arguments, but in our version it's going to receive three, which is the abstract machine, the functor, and the register.
Well, we should probably explode the functor into a string and an integer, I guess.
Oh yeah. So yes, I would also advocate to making the computer. The computer should have the H register, and it should have at least 8 X registers, right, Marinho?
I'm not sure. I don't recall off the top of my head how many registers this thing is supposed to have.
At least 8. Look at my screen if you need to.
Oh, let me remember how to do a signature no Como.
I don't think there's actually a bound on those for the
I
abstract
think the
model.
signature occurs in another file, Mageta. I think it's the MLI file.
No, it doesn't need to, as far as I know.
Oh, okay. I would advocate to
Well,
8 for now,
I
Marinho.
yeah, it's for the entire module, but whatever, man. Just keep going.
Okay, so we need three things in the computer.
Oh, it's system one.
We need the heap, we need the array of X registers, and we need the H register. Those three things for now.
After enclosed. I see. Okay. And then this. I see. How do I do that still? Wait a sec. Let me just see this. Oh, it was like that. What the heck? Yeah, there we go. Weird, isn't it?
Weird, isn't it?
Sure if this was, yeah, this was needed. So we need to do a signature and um so as far as I remember, I'm just recalling how to do a functor here, okay?
Okay, now let me search
So,
for that and try to help you. Functors.
uh
OCaml.
I think they have a name functor, do they? Yes, there is. And then you pass the module here. And then you can use the T
Okay,
as
I
T. Okay,
found
that's
I
fine.
okay, but I found the syntax. I'm gonna
Yeah,
put
well,
in the chat
let's not
anyway.
use that now. I just want to know because it might be useful for the
Sure,
computer.
sure, sure, sure. Okay, so
It's
the computer should have three things inside it.
more like compute, I
It should
guess.
actually should I think it should be a record, the computer.
So I want to make a type computer.
Yes.
What is that?
That is composed out of three fields in the record. First
The
one is
heap,
the heap,
which is the
that thing there, yeah.
ah this
Yeah. The second thing,
with cell. So cell dot t.
yes, yes. Second thing is an array of registers. And a register is just a number.
Okay.
So let's put 8 registers in for now. I don't know if you can make arrays
What
with.
is a register? Just integer?
Yes.
Well, actually, a register should contain a cell.
Oh, yeah, that's true actually. It should contain a cell. It doesn't need to
Okay.
be an array. I said it like metaphorically. It can be whatever sequence you prefer.
Well, list.
Then, okay. And the third thing is the H register, which is a special
Wait a
register.
second. Why is this complaining?
Do we need commas?
Expect zero. Cell t expects zero arguments. What do you mean? Huh? Cell t expects zero arguments. I'm not passing an argument to it. I don't know if you noticed.
Wait. Oh no. Yeah, I don't know, man. Okay, move things.
Wait, man.
Oh,
The
I think I see the problem. The end is. Wait. Well,
this is
no, cell
fine.
is a module.
Like this is fine. Why when I add this, it is not fine?
Are we missing syntax by any means? Oh yeah, semicolon.
That's not needed in F sharp. Don't know why it's easier.
Okay, the final thing is the H register because it is different than the other registers.
The what register?
H H register, and it is a cell as well. No,
Actually, it should be an index into the
yeah,
heap.
this is the one that is a number, so this is the integer one. My bad. Okay, we are ready. We're ready to create the first function. So the put structure function receives three things: uh, a f- uh, the index of a register, the index of a register, a functor. So in this case, should be a cell, right? Marinho, am I saying things
More
correctly?
like term, I think.
No,
If you
but
make
the
it,
put structure needs to be a structure, needs to be a functor.
no, it needs to be. It doesn't need to. It needs to be a functor in the sense of the functor case of a cell. The problem is if we make this receive a cell, it's not
Oh,
quite
I see.
type safe because we can pass it a structure or a
Exactly,
reference.
exactly.
I see. So it needs to be
Let's make this a pair for now. Yes,
done.
yes. And the final thing is the
I
computer.
can use this. Done.
And then the final thing is the computer. That's it. So now let's implement it. So the first thing that we need to do is to extract the H register from the computer.
Let me look at the paper.
I'm sharing my screen yet. Still.
Okay. So we pick the
You need to pick the H here.
heap. So that is assigning the
That in
structure
yes.
with H to the heap on the position of the H register.
Yes, we are indexing using H on the heap
So
and
heap.
putting this cell in it.
Oh, so here's one thing that we don't have. Um, okay, so the H starts at 0, right?
I think so, right, Mari?
Well,
Does that
I'm guessing
make
it does.
sense? Well, that does, but here's the problem. Our heap is dynamically allocated.
Actually, here's a bigger problem. Our heap grows at the beginning.
Wait, doesn't this heap also grow in the beginning? This one? Or am I going insane?
No, the heap doesn't actually grow. It's an array. It's a memory. It's meant to be a memory.
They just did a malloc, and that's it.
No, but we're gonna do that in the entry point, right?
No, here's the problem. The type that we're using to represent a heap is a list, right? A
It's a
sequence.
sequence, yes.
You cons onto the front. That shifts the contents of the entire heap by one space.
Ooh, that is correct.
Mhm.
Well, but you can swap the sequence for something else later on anyway. So I think we can just keep going implementing put structure and the other functions today. And then off, we just swap the sequence to the finger tree implementation that you found.
We will use batteries.
Yes,
Amazing.
we will use batteries. So let's go back to the implementation. Here's it is, Mageta. So what are you going to do? You're going to index the heap using the H register, and you're going to put
That
this cell in it.
that won't work probably.
Really?
Yeah, because it's a sequence. I mean, I can do this, I suppose. No,
I mean, I
there's no
suppose
positional
actually
option.
we could just push the new cell into the front of the heap. That should work, I think. But then
There
we are
is,
deviating
yeah.
from the book.
So there's no. I don't think there is on the sec a nth access on the
Oh, okay.
position.
That's a problem if it's true.
So if it is a list, I think you can.
Yeah, no, but
Yeah.
I mean, the operation that we're doing here in this particular instruction, we could implement it as just consing twice. But the problem is then that we're shifting the addresses of everything. And also,
Memorize,
hmm,
transpose.
And there's none because it's lazy, right?
and it's a linked list as well. So,
Okay, so apparently we can't use sec as a mock for this. She's kind of sad. She's kind of sad. Okay, what do you guys think about doing the following? We just implement the functions assuming that we have an
Oh
array.
wait, there's a find index on
No,
the
but you need to
sec.
pass a predicate.
Well, yes, you need to find it.
Well, but what we want is to have an
But
index.
oh yeah, you're finding the index based on the value.
Exactly.
Never
We
mind.
want to do the
That's the opposite.
opposite. We have the index already and we want to query on it.
well,
Okay,
So
you
sorry.
could just do a drop followed by a uncons.
No, no, sorry. Wait a second.
Oh, that was very Marinho, man. That was very fucking Marinho.
And as long as you don't throw away the original list, you should be fine. But the problem is that this is linear, right?
Okay, I have another proposal for us to be able to get up to speed here. What if we put the signatures of those functions, like put at a specific index on the module of the heap, and we care about the internal implementation layer later on? What do you think?
I think that's sensible, probably.
Okay, so let's do that.
Okay, what we were discussing was away.
Okay, so online I suggested to Marinho and Marinho agreed. Let's make a signature in in the heap module called put that you pass an element of the type T, well, of the type A, and an index, and just do undefined for now. We're not
So
gonna
you
implement right
pass.
now.
Okay, that'll be
You're gonna pass
sad.
the structure, so AT, oh heap, and you're gonna pass an element. You're gonna pass an index, an integer, and undefined, whatever is in OCaml, which I don't know.
An integer, so position.
Yes,
Oh, index, whatever.
yes, exactly. And then later on, we're gonna finish this module to do the thing. Okay, so now let's do it. I would suggest doing a let on the put structure to extract the h. So like let h equals, and then you remove something from the computer. Does that make sense to you, Magette?
You could just do computer.h register, no?
Well, that works for me as well, but that's kind of a little bit too long. But okay. Is Magetta alive?
In.
Okay. So did you get it?
Let me do one thing here.
Sure.
And come on. I know I don't need to do all this. Just one. Okay, thank you.
Yes. Okay.
Okay,
So
so
uh,
describe again.
l- let's make the new heap, right? Because we're gonna mutate the heap, but we're using immutable stuff. So let new heap equals.
Okay, man, instead of saying like what to do, describe what's the intent. I
Okay,
think
the
it's easier.
intent is we're gonna pick the heap at the
Mm-hmm.
h register index position.
So wait. We're gonna pick the heap. So
Use a put on it.
as
Yes,
I know
as
it's not the syntax. I
yes.
just want to know
H
with the
register
H register, okay,
equals. We're gonna
and
put
then
a
assign
functor.
this garbage,
Assign this garbage to a cell in which is a functor.
which is the functor cell.
Yes.
Is that it?
No, but we need to wrap that with a functor tag.
Oh, it's a new one. So it would be functor.
Functor
Uh,
cell.
what's the string and what's the?
It's the arguments. Functor cell.
So okay, it is both
The
Yes.
the
string
string.
and the integer, yeah.
Yes.
I see. So it's just functor cell.
That's
I
all we
see.
need to do.
Okay, that's simple. So I think we can just do then. Oh, that should be just the put then.
Exactly.
Okay. So heap put. And by the way,
This should return a new heap.
yeah. So heap. The element goes here. Okay. And why is this broken? Expects two arguments.
Do you actually need to explode the pair in order to construct a functor?
That would be very cringe.
Whew, that would be cringe. Like, come on, man. Come on. Come on.
Like, could it be because it curries? Because I know that when you have this is a function with arguments, right? And then if they decided to curry these guys, then it makes sense. But why? In F sharp, it's just one value
Well, I was expecting
always.
it to be one value.
That would be ultra cringe. That's
We gotta do what we gotta do.
well, functor uh
It is
index
index. Yeah. No, arity. Arity. This is not
arity.
index.
Yes.
This is arity.
Well, that there's no reason why this shouldn't work. That yeah, that was it,
Okay,
Maria.
but
It is
make a
open
let.
range.
We are gonna receive the new heap. Okay. Next step. I think we should do another let, by the way.
Of
It's gonna be another heap we're gonna create a new one using the previous one.
a new one. Okay, update. You mean?
Exactly, update the previous one.
Okay.
Um, which is gonna be uh, oh man, I think it's easier for you to just see my screen instead of trying to explain. Basically,
Oh,
we're
we
gonna
can,
put in the
hmm.
next position of h the functor.
I'm gonna wait. Let me put the
Oh,
failure
I
free.
Oh,
think
we
that
did
was
we did
actually.
bullshit. We
Yeah,
did
no,
bad
that's
there.
backwards.
That's
First, we need to
backwards.
put a cell containing a structure pointing to the next address, and then we put the functor in there.
Yeah, yeah, yeah.
Yeah,
So
to the
save line
next
38.
address.
Yeah, save that line 38 there. This is correct, but not now.
I don't get why they do this though.
What?
Like, they have the functor, which is essentially the header of the structure, but then they put a pointer to the structure immediately before it. What's the purpose of that?
Well, I don't know yet. But
Yeah,
this
that
is this is
made
not
very
correct,
confusing.
Magetta. Go Control Z on that. Control Z on that.
What? What is not correct?
Yeah, we mix things up,
Oh,
and
that's
that was my
H.
fault.
I see.
That was my
That's
fault.
H register plus one.
Yes.
I see.
Yes, exactly. Then,
And then
uh,
this.
yeah. Uh,
Ah,
oh, that means we
oh,
should put the
I'm
we
cringe.
should put the put with the heap at
Yes,
the end, man.
I unlike SML here. Why don't you guys curry stuff? Because we feel like it. I feel like not doing it.
Yeah, but now you need to
Uh,
put the initial heap in there, yes. So let's see. The first thing that we do is to create. Oh, but that's still wrong. On the second line, the first put, it should not
wait,
be
that's unbound variable functor. What do
it
you
should not be
mean?
functor. It should be structure in there.
What do you mean?
This first put that you're putting h plus one, it should not be a functor. It should be a structure.
Oh, the first,
The
indeed,
first one.
yes. But why is it still complaining? I don't
And you can
follow.
remove the functor label as well. This is just a number.
Yeah,
Okay.
I need to do this.
Yeah.
Oh man,
Okay.
why is it complaining constructor, unbound constructor structure?
Do you need to do cell dot?
That would be very cringe. I don't think so. What? Oh,
Tommy.
because that is not open. I
Oh
see.
yeah, that is not open. That is also
Okay,
true.
let's give you that. Right.
That is very very true.
Okay.
The age register online, the one above should be age register plus one
Oh,
actually.
indeed.
Exactly. Also, that's also true.
Uh, wait, here, right?
Yes, this one.
Yeah.
And that's kind of it for heap. Which, by the way, the return of this function is a new computer. So we're gonna create a new computer in which the final heap is this one.
Okay. Oops.
Okay. So, but that's still not we're still not done. We still need to do two more things
Uh,
before. But about the heap,
okay,
that's
but
it.
the other things I gotta do are, uh, we just assigned a functor. We pick the xi,
Yeah, you
and
put
when
the
we
value
assign the register.
exactly. You pick the current h, use it as an index to the heap, and put that in the register that we are receiving, index of register in the arguments.
Mm-hmm. So
Like,
we
Okay.
pick then a gometing.
couldn't they just have put the structure in the register? Like the structure cell, I mean the str h plus one inside of the register directly? Like,
Ah, I see what you mean. Okay, Maget, let me explain. You see that we
Mm,
are putting this structure inside the heap at the h position?
that's a
yeah.
reference to the structure that we're about to allocate,
Exactly.
but I
But then
don't.
we instead of doing this directly to the register, we use the heap as a middleman.
No, no, but the point is it gets saved on the heap. I don't get why they do that.
Save on the heap, you mean?
Yeah,
Well, I thought we are definitely using that in the further steps that we haven't read yet. At least I haven't.
maybe this might be related to whatever memory management strategy they
Yeah,
the
maybe that's the case. Okay, so which one you want to do first, Magetta? This one or this one?
Just a sec. You're gonna cringe now. Okay.
What?
What's the thing? No?
We're gonna pick
Assigned
the.
register.
Yeah, we need to assign the register the heap at each position.
So we're gonna have to do this here.
Mapi.
Yes.
Uh, oh fuck me! I know what you're doing. Okay, Maylin, do you know what he's doing?
I wanna cry.
I know what he's doing.
If I
Ah,
equals
fuck.
to index of
what is
register, then we assign with the heap.
No, 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 no,
So
no. Wait. Oh
so
no,
the
it is
data in
correct. It
the
is correct.
yeah, but the data
Fuck.
in the heap is this guy, right? The structure.
The data is that structure, yes.
So that else then oops, I do need this.
we could just save that structure cell,
We could. We could. Yeah, we should.
like
We should.
give it a name, and then we can not.
Duplicate it in the code.
Yeah.
Yeah, after Magetta pushes this, I'm gonna fix it, Marinho. That's okay. These are
Okay.
the new registers, though. Save this in the let binding as well. Okay, and now we're gonna return the final computer.
Let me put this in on the line above because it's gonna be aligned at least.
But now we are
Oops.
returning the new computer.
Yeah. So okay, now it's just updating the
Yeah, so heap is heap, register is
computer.
registers,
Oops. So it is just heap
registers,
registers
and heap register h register plus 2.
plus two.
Yeah,
Indeed.
because we did h and h plus 1 in a single
Okay.
in this instruction. And that's it. This is the
Right.
final this is the final thing.
I think if we want to do it like this, let me do h registered plus two. Then I think, oops, then I think this should work. Yeah. And then we can do it in here. That's better to read.
Yes.
Not really.
Okay, let's finish today with these two other functions which are very simple. Next function,
Let me
uh,
copy here.
it's gonna
So
be
describe to me what it, oh, a set variable if I
set
don't know
variable.
that.
Set variable. And it receives the index of register as well. And what are we gonna do? We're gonna change the heap again, and we'll receive the computer, of course.
Uh-huh. So okay, we do the same update, but on the,
It's on the heap on the H register position again, but instead
mm-hmm,
of saving a structure
we
of,
save a
we
reference.
say a reference.
Oh, okay. I remember now why they save a reference structure before the structure. It's because um, variables cannot refer to registers. They must refer to the heap.
It's not a register plus one. It's just register.
I just, oh, right, I was looking at the wrong one.
Yes. Okay. That's it. Then we're gonna do the same
Uh,
mapi nonsense that you did.
okay, but wait. This is on the H
H.
register.
Yes. H. And you put heap in there.
Okay, and then heap. Okay, what's next?
Next is the same as line of the mapi nonsense. It's exactly the same.
Wow, I
But
love
instead of
this.
structure, plus one, it should be the reference, right? We should make a let for that and save it and use it twice.
I can't use a ref because that's a thing. Ah, this is ultra cringe.
Relax, man. We're gonna make it better.
Uh, I use the structure here twice. So structure, which I can't also use. I mean, I can. Um,
What a manual
true.
made to not be done in OCaml.
Okay, it's called stru. Is that okay?
Yeah. Okay. And then the final piece of the puzzle is to create a computer.
That's slightly better to read, I suppose. Not that
Yes,
much.
I would say it is slightly better to read. Don't forget the in though.
This was a structure, right, as
Yes.
well.
So this
Oh no,
is
this was. Wait, no, no.
this is true.
This. Wait, no, wait. We are reverted, right? So this is the functor.
Oh, this is the second. This is the
Yeah,
second thing. Okay, that makes
func.
sense.
Oh, I forgot the. I forgot the other let. Yes, func. There you go. Ugh. Oops, and I forgot again about the ing. Man, I'm gonna keep forgetting this all the time.
F sharp poison.
Yes, it's I'm poisoned.
Okay. Let's go
Is
back
it
to
better
set
to do this?
variable.
Yes, so.
I think it is kind of better. It is kind of cringe because it looks like an imperative program, but it is okay.
Yeah,
Uh,
in reality, it's just a monad. But yeah,
It's the identity monad.
yeah.
that's true. Okay, let's make the new H register as we did before. We also need to make the new one here.
So we updated, and then we just assign. We update the h again.
Yeah, this is plus one instead of plus two.
Okay, so let h register equals to h register plus one. I forgot again about the in, man. Should do it automatic at this point.
It's muscle memory.
Now we're
Yeah,
gonna make the computer.
heap
Heap, registers, and H register.
registers h register.
And that's it for this function.
Next,
Final function for today is set value.
set value,
Receives the
which
index of register as well in the computer.
well, that's just trivial.
What we're gonna do? We're gonna put.
We don't even need the
Wait a
register. Oh
moment.
no, we
Wait a moment.
do.
Marinho, you need to help me here. Set
Yes.
value is grabbing the value of the register, right?
Yes, it is.
Okay, so we need to do an indexing on the registers.
We need to find the value first.
Yes.
Value of register,
And then you need to use the index of register as an index.
which will probably be an optional, so I can already tell the beauty.
It will
And then
probably
we
be an
put
optional.
that, and then we put that here.
Yeah, that is
On the
correct. That is
on
correct.
the same H,
And then you
and then
increment
we
the H
update.
register,
Let me copy these already. And oh, actually,
and
both are.
and then you create the new computer.
Okay,
And
now
that's
let's
it.
find the friend. So
Yeah.
it is on the position I.
Yes.
So it is on based on the index. So registers list.inf. I guess that's it. Uh,
You need to
which
pass
one do we
the
pass first?
index.
The
You pass
index.
the index of register at the end.
Okay,
And that's
that's it.
it. Those are the functions for query terms. So these are the three ones that we did. These 3 ones.
And we're gonna make it better later, right?
Well, I
No.
want to. No, we will make this better later. There's no fucking way.
Mhm.
Put doesn't even make sense. Put doesn't is not even implemented. Uh,
Are we also going to work it harder?
Well, we can solve it by adding a list.
no man, we're
Like
gonna use the fucking finger trees that Marinho found.
ah, I'm sorry, but I'm not gonna.
I will be the one doing that.
Yeah, you're gonna suffer with Emacs tooling. Good luck.
That's
With not
okay.
Emacs, sorry, OCaml tooling.
That's okay. That's okay. I accept my fate. I embrace it. Okay. Now. Well, I think that's. We are here for like how much time? 1 hour already. Do you
12,
guys want to
but we've been
go on?
talking.
No, yeah, but it's already 1 hour
One
of
commit
recording. Do you
list.
want to keep going?
Um, I don't think I can much longer because I still need to sleep
Okay, let's do the following. I will finish
early.
the recording.